Hello, my name is Nicholas Lawrence and my student ID is DSC2409079. And today, in this presentation, I will present about the application of derivative to the economy and the water method, and the last one will be the moment and the center of the mass. So the first one, I will explain about the application of derivative to the economy. The cost function, average cost function, revenue function, average revenue function, profit function, and average function. And I will give 3 examples about that. So first, I will explain about the cost function. The cost function is the total cost of producing a certain quantity of goods or service. Express how production cost change with variation in the quantity of output. The cost function is typically usually represented as cost of ads, where the cost of ads is the total cost and ads is the quantity of output being produced. So usually in the cost function, they usually have divide into two. There is the fixed cost and the variable cost. The fixed cost is something already fixed. The businessman we usually already count that beforehand. They already know what is the value of the fixed variable. The fixed variable, something like electricity, the worker salary that will never change. And the variable cost is something that will change the value of the total cost. Usually is the number of material being used that usually can be increased or decreased during production. The application of derivative to the cost function is usually called as marginal cost. It represents the additional cost of producing one more unit of output. So business company usually use this marginal cost to determine the level of output at which the cost of production increase or decrease. So they can find the most efficient cost production to produce the maximum profit. Next, I will be explaining about the average cost function. The average cost function is the cost per 1 unit of output. So we can write the formula as the cost function divided by the unit of output that we call as ads. So the derivative means the rate of change. That means the derivative of the average cost function will give the rate of change of the cost per unit as the production change. And the business company usually use this average of cost function to identify the output level at which the average cost is being minimized. The derivative of the average of cost function is the marginal cost subtract by the average cost divided by the quantity, or we call as ads. We can get this by the quotient rule and the substitution.
Now I'll be explaining the first example of the question about the rate of change of cost function. In the question, it said that the total cost is in dollar incurred each week by this company for manufacturing ads refrigerator is given the cost function. The C of ads is 8,000. 8,000 is the fixed variable plus 200 ads minus 0.2 ads squared. That is the variable cost. The ad is between 0 till 400. The first part is they ask about the actual cost incurred for manufacturing the 251st refrigerator. That's when they ask about the additional cost for producing the 251st refrigerator. To find that, we need to deduct the value of the total cost of 251 with 250. Next, part B. The rate of change of the total cost function with respect to ads when the ads is 250. So the rate of change means the derivative of the total cost function, and we need to differentiate this function. Then part C, compare the result obtained in part A and part B. In part A we get 99.8, while in part B we get 100. And both of the value is quite close to each other, and the company can use this derivative function to find the additional cost for producing one more product. That's where the 251st product refrigerator. And why there's a slight difference between part A and part B. Part A is 99.8 while the part B is 100. Because the cost function 8,000 plus 200 minus 0.2 at square is a curve. So we use the differentiation to this cost function is to find the additional cost, like the approximation, to find the additional cost.
Next to the revenue function. Revenue is equals to the number of units sold times the price per unit. So the derivative of the revenue function we call as the marginal revenue, which indicate the additional revenue from selling one more product. So the company, the business company, will use this marginal revenue to determine the optimal pricing and quantity to maximize the revenue. Next, I explained about the average revenue function. The average revenue function, as I explained before, the average is the revenue earned per unit of output or per one unit. So the function of average revenue is the revenue function divided by x. And the derivative application on this average revenue function is to analyze the effect of pricing decision on per unit of revenue. And to find the derivative function of this average revenue function is just use quotient rule and substitution, and you will get marginal revenue subtract by average revenue divide by x.
Next, I will explain the example for marginal revenue function. So in the question stated, suppose the relationship between the unit price P in dollars and the quantity demanded X of the company model F loudspeaker system is given by the equation P equals minus 0.02 X plus 400 with X within 0 to 20,000. So the part A, find the revenue function of R. The revenue function is the unit price times with the quantity demanded. That is the revenue function. This is the revenue function. Next is the question is asked about marginal revenue function, and this will be the marginal revenue function. Next, C. Compute the marginal revenue with X equals to 2,000. So what we can know from this value 320. So when the quantity demanded is 2,000, the marginal revenue is 320. This means that producing and selling one more additional unit will increase the revenue by $320.
Next to the profit function. How I get the profit function is by subtracting the revenue functions by the cost function. The use of derivative of profit function, which is called as the marginal profit, is to determine the level of output to maximize the profit. Next to the average profit functions, the average profit function is the profit earned per unit of output. So we can say the function is the profit function divided by the x. The application of derivative to this average profit function is to analyze the effect of pricing decision on per unit of revenue.
Now I'll explain the example 3, which cover the marginal cost, revenue, and profit. So in the question gives the unit price function, which is 600 minus 0.05 x, with x within 0 till 12,000. And also give us the cost function, which is 0.00002 x power of 3 minus 0.03 x squared plus 400x plus 80,000. So part A, find the revenue function and the profit function. And first, we need to find the revenue function first. So the revenue function is the unit price times the quantity demand, which is 600 minus 0.05 x times x, and you get the revenue function 600x minus 0.05 x square. And to find the profit function, you need the R revenue function subtract the cost function, and you get the profit function, which is minus 0.00002 x power of 3, then minus 0.02 x square, then plus 200x minus 80,000. And this is the profit function. Now next, the part B, find the marginal cost function, the marginal revenue, the marginal profit function. So we just need to derive all the function. Like next, the part C, compare the marginal cost function with is 2000. So what we can interpret from this result is the cost function, the additional cost for producing one more product is $304, and the revenue, the additional revenue to produce one more product is $400, and the profit will be plus $96 if you produce one more product. That means the 2001st product. And from this value, we also can compare between the cost revenue, the marginal cost and the marginal revenue. We can see that the marginal revenue is higher than the marginal cost, which means that this is called as inefficient, which is you can produce more product to increase the profit. Washer method. The washer method is a technique used in calculus to find the volume of a solid revolution when the solid is generated by rotating a region around an axis. So take an example like this picture below. If we rotate this against this axis, we will generate a solid revolution by rotating this axis. And to find the volume, first we need to find the area of this. To find the area of this, we need to know what's the formula for area of a circle. Area of a circle is V times the radius square. So to find this area, we need to deduct the area of outer circle with the area of the inner circle. To do that, the formula is this, stated here. V opens R square, the R is the outer R, minus R inner square. Then after we know the area of this is the delta X, or we call it as the head of the washer. Then the head of the washer, if we times this to the area of the washer, we will get the volume, the volume of the of this. Then next, if we divide this washer into so many this, we divide it until n close to like large number, we can write it as limit n approach to infinity, like this statement. Then we this is just the same with v integral with upper limit at b, here b, then a as the lower limit. And this formula is to find the volume of this whole solid generated by rotating this axis. Next, I'll explain the question example. Find the volume of the solid formed by rotating the region between y equals to square x and y equals to x over 2 about the x-axis from x equals to 0 to x equals to 4. If we can draw, this is the y-axis and this is the x-axis, then the y equals to square x will be something like this. Then the y equals to x over 2 is a line with something like this, and then we have x equals to 4, and this is x equals to 0. So by rotating this region will form a solid form. But to do this, we need washer method that I just explained. The formula is phi integral the upper limit and the lower limit, and the r outer, the radius of outer and square, minus the r inner square, and the head of the disk that we're gonna divide is called as delta x. Then from the picture, we know that the upper limit will be 4 and the lower limit will be 0. So we can write this 4, then this 0, and the radius of outer is square x, then part of 2, and the inner will be x over 2 part of 2, and dx. 340 and then square root of x power of 2 will be x minus x square over 4 dx. So we'll integrate this function. We'll get square over 2 minus 1 per 4 x power of 3 over 3 with the upper limit is 4, then 0 and will be 4 square over 2 minus 1 over 4 4 power of 3 over 3 minus this 0 0, then this will be 0. The next is this is 16 over 2 is 8 minus 1 over 4, this 16 over 3. Then the answer will be the answer will be 8 over 3 v. This will be the volume of solid from the moment of a point mass at a distance d from a reference point is defined as the mass times the distance will be the moment. So for a many point of mass, the total moment is the sum of the individual moment. Like in the graph, there will be a lot of points with different mass. So we need to find the moment of x, the moment of y. To find the moment of x, we just need the total of m1 times the y1 plus y2 plus y3 until the end, and the moment of y will be the total of mass times the x1 plus x2 x3 until the end. Next to the center of mass, let's take example from this picture. To have a balanced road, you need to have a equal moment between the left and the right. They need to have the same moment. So this x bar is the coordinate of the center of mass. That this must be equals that if we take out the x bar, I mean the coordinate of the center of mass, the x, we will get this formula. And this formula is to find the coordinate of the center of the mass x. And we can apply this the same to the graph with so many points of mass. X bar equals to the total moment of y per the total of mass, and the y bar will be the total moment of x divided by the total mass. Now I'll be explaining about the example question about moment and center of mass. In the question, they have mass 3, 4, and 8. The point is 1, 1, 2, 1, and 3, 2 respectively. Then first we need to find the moment. The moment of y. Then after that we need to know the total mass. The total mass is 3 plus 4 plus 8, which is 15. Then we can find the center of mass, which is the as well the centroid. Then the moment of y is 35 divided by the total of mass, which is 15. We can simplify with this becomes 7 over 3. Next we need to find the y bar. The ms will be 23 over the total mass is 15. Then we get the center of mass. The center of mass is 7 over 3, 23 over 15. This will be the center of mass. That's all from my presentation about 3 tasks that are given. I apologize if there are any mistaken in my presentation, and thank you for listening to my presentation.